Let's order rational numbers. Use the symbols greater than, less than, or equal to compare each pair of numbers. Be prepared to explain your reasoning. So for the first one, 19 is bigger than 12 because 19 is further right on the number line. For the second one, 212 is bigger than 190 because it's further right on the number line. 15 is 10 times further to the right than 1.5 on the number line, so 15 is bigger. For the next one, that's like having $9.02 compared to $9.20. One has 2/100ths and the other has 2/10ths, which is bigger. Then in the next one, 6.050 is equal to 6.05 because you have a 6 in the ones place, you have a 0 in the tenths place, you have a 5 in the hundredths place, and a 0 in the thousandths place. Even though the one on the right doesn't show it, it's implied that there's a 0 there. 4.4 is the same as 4 over 10 if you write it as a fraction. And then you can make an equivalent fraction of 16 over 40 by multiplying both numerator and denominator by 4. And now it's easier to compare 16 over 40 to 9 over 40. With 16 over 40, you have more pieces of the pie. You have 16 out of 40 pieces compared to 9 out of 40 pieces, showing that that one's bigger. Another way to have figured it out that maybe not everyone would have spotted, but if you take 1/4, which is 0.25, well, on the left side, 0.4 is bigger than 0.25. But on the right side, 9/40ths is less than 0.25. And how we know that is because 10 out of 40 would be 0.25 or 25%, and this is less than that. It's 9 out of 40. Now, picture the denominator of a fraction as one big piece of pizza that you're cutting into many different slices that make up the whole. So one of the pizzas you cut into 24 pieces, and the other pizza you cut into only 21 pieces. So those slices are going to be bigger. 1 out of 21 is bigger than 1 out of 24. So because of that, 19 of those bigger slices is a bigger number than 19 of those smaller slices. Now going along with that same logic for the next one, 1/12 is bigger than 1/17. So if you look at 16/17, you're missing just 1/17 to make a whole number. And then on the right side, you're missing just 1/12 to make a whole number. But 1/12 is bigger, so you're missing more to make the whole number. So that one is less. And 16 over 17 is the greater number. Another way to look at it is to just take 1/2 and then take 99 over 100. Both have the numerator as 1 less than the denominator, like the other example. However, a half is equal to 0.5, and 99 out of 100 is equal to 0.99. So 0.99 is bigger than a half. So the 16 over 17 is bigger than 11 over 12. For this activity, you would have received a set of cards, but if you didn't, you can just use the black numbers that are on the screen. That's the first set of cards. You need to put them in order from least to greatest, exactly like you would see on a number line. After you're done with the black numbers, you're going to put the second set, which is the pink numbers, in between the black set in the places that they go. So pause the video and please work first with the black set. When you're done with the black set, add in the pink set. Now you've finished the activity and you've unpaused the video. Go ahead and check your answers. Did you start with -23 all the way to the far left and end up with 100 all the way to the far right? Check the numbers in between. Use each of the following terms at least once to describe or compare the values of the points M, N, P, and R. Greater than, less than, opposite of, or opposites, and negative number.
So we can use greater than when we say R is greater than M. We can use less than when we say N is less than P. We can use opposite or opposites with P and M. So P and M are opposites. You can tell because they're both equal distances from 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in the other direction. And for negative number, N and M are negative. Tell what the value of each point would be if P is 2.5. So if P is 2.5, then that means these are going by halves. Half. Six halves, 7 halves, 8 halves. So that means R would be 8 divided by 2, which is 4. N would be -1. M would be 1, 2, -2.5. And that makes sense because it is the opposite of P.
For the next one, B, N is -0.4. So if N is -0.4, then that means each tick mark is going by 0.2.
M is -1. So since P is the opposite, P would be +1. And R would be 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6.
C says R is 200. So if R is 200, then that means each of these tick marks is going by 25, 25, 50, 75, 100, 125, 150, 175, 200.
N would be -50. And M, -25, -50, -75, -100, -125.
Next, M is -15.
Then we are going by threes. 3, 6, 9, 12. And these will be negative. So N would be -6. P is the opposite of M, so P would be +15.
And then if we go by threes in the positive direction, R is 24. Woohoo! Drinks for sale.
A vending machine in an office building sells bottled beverages. The machine keeps track of all changes in the number of bottles from sales and from machine refills and maintenance. This record shows the changes for every 5-minute period over 1 hour. So here's the 5-minute periods on the left and how the bottles are changing. Not the number of bottles in the machine, just how are the bottles changing from each interval of 5 minutes. So given that, what might a positive number mean in this context?
Well, a positive change would mean there was maintenance done to the machine and drinks or bottles went into the machine. What would a negative change be? A negative number would mean that bottles were coming out of the machine, meaning students were purchasing drinks. What would a 0 in the second column mean in this context? A 0 would mean that no one bought anything and there wasn't any maintenance done to the machine. Which numbers, positive or negative, result in fewer bottles in the machine? Well, obviously, negative numbers. Negative numbers for change would result in fewer bottles in the machine because that means people bought bottles. Bottles came out of the machine. At what time was there the greatest change to the number of bottles in the machine? How did that change affect the number of remaining bottles in the machine? So it looks like the time from 850 to 854, there was the greatest change in the number of bottles in the machine. And how did that change affect the number of remaining bottles? Well, it increased the number of remaining bottles by 24.
At which time period, 805 through 809 or 825 through 829, was there a greater change to the number of bottles in the machine? Explain your reasoning. And 825 this time. So which experienced the greatest change? I'd say neither, because one was a positive 12 and one is a negative 12. So they both changed by 12, except one, for one time, they were adding 12 bottles to the machine. For the other time, they were taking out 12 bottles. Neither at both times the change was 12.
Or at least absolute value of 12.
The machine must be emptied to be serviced. If there are 40 bottles in the machine, when it is to be serviced, what number will go in the second column in the table? Well, if there's 40 bottles in the machine and you have to take out all the bottles to be serviced, then it would be a negative 40 that would go in the second column in the table, right here. Okay, to summarize what we learned, what are some situations where negative numbers make sense? Elevation, temperatures, this vending machine situation. What do positive and negative mean on a number line? Is 0 positive or negative? Positive just means it's to the right on a number line, whereas negative means it's to the left of 0 on the number line. 0 is not positive or negative, it's neutral. What are some ideas you have about opposites? What is the opposite of 0? Again, 0 doesn't have an opposite. It's right in the middle of the number line. A number and its opposite, like 5, the opposite would be negative 5. Both of those are equal distance from 0 and have an absolute value that is the same. How can you tell if one number is greater than or less than another? We'll know a number is greater if it's further to the right on the number line. So now is time to take your cool down.
Select all of the numbers that are greater than negative 5. 1.3 is greater than negative 5, so is 1/7. Negative 1, negative 4, whereas negative 6 and negative 12, those are to the left of negative 5 on the number line. The table shows 5 states and the lowest point in each state. Put the states in order by their lowest elevation from least to greatest. So the lowest elevation would be negative 282, which is California. Next would be Louisiana at negative 8. Then New Mexico at 2,842. And lastly, Colorado with 3,350. Here are the boiling points of certain elements in degrees Celsius: argon, chlorine, fluorine, hydrogen, and krypton. List the elements from least to greatest boiling points. So the lowest boiling point would be hydrogen at negative 252.87. Then we would have fluorine, negative 188.1. Then we would have argon, negative 185.8. Then we'd have krypton, negative 153.2. And lastly, we'd have chlorine with negative 34. With negative numbers, the greater the absolute value, the smaller the number. Decide which of the following quantities can be represented by a positive number and which can be represented by a negative number. Give an example of a quantity with the opposite sign in the same situation. Tyler's puppy gained 5 pounds. That would be represented with a positive number, and the opposite of that would be Tyler's puppy losing 5 pounds. The aquarium leaked 2 gallons of water. Leaking water would be a negative number, and the opposite of that would be the aquarium gaining 2 gallons of water. Andre received a gift of $10. Well, he's receiving it, so that's a positive number. And the opposite of that would be Andre giving away $10 instead of receiving it as a gift. Kieran gave a gift of $10. Well, the opposite of him giving a gift would be him receiving a gift. And then him giving away money would be money going out, so that's a negative. Could be represented with a negative. A climber descended 550 feet. So the climber would be going down, so that would be represented with a negative number. And the opposite of that would be a climber ascending 550 feet. On the number line, label the points that are 4 units away from 0, so here at negative 4, and also positive 4, 1, 2, 3, 4. If you fold the number line so that a vertical crease goes through 0, the points you label would match up. Explain why this happens. This happens because those points are opposite each other on the number line. Or in other words, they're equal distance from 0, but in opposite directions. On the number line, label the points that are 5/2 units from 0. What is the distance between these points? Well, 5/2 is the same as 5 divided by 2, which is 2.5. So 2.5 units away from 0 would be the number 2.5. And then 2.5 units away from 0 going left would be negative 2.5. What is the distance between these 2 points? You can count 1, 2, 3, 4, 5. The distance between both points is just 5.